Good evening. I had a few students ask me about domain and range when given a function or when given the graph of a function. So I wanted to post something really quickly with a couple of examples to walk through together. So we right now have about 4 different kinds of functions that you're going to be seeing. The first kind of function we'll see are polynomial functions. We know they're polynomials because all of the variables in the equation have a positive exponent. None of our variables are in a denominator position. So for example, f of x is equal to 3x squared plus 4x minus 9. So anytime we're dealing with a polynomial, our domain is always going to be negative infinity to positive infinity because I can put any real number into this function and it's going to give me an output value that is real. Unless we do a special definition of the domain for certain word problems or later when we're doing inverses. Otherwise, we just assume it's always from negative infinity to positive infinity because the domain deals with what kind of inputs can I put into this function to expect to get a real number output value from this function. For the range, that's a little trickier. This kind of function, because it's a quadratic, is going to have a shape like a parabola. I went ahead and graphed mine using my calculator just because we really haven't talked too much about graphing quadratic functions. When I graphed that function, I asked it to find for me the minimum on my calculator, and when I did, it gave me this point of negative 2 over 3 with the y value of negative 10 and 1/3. So when we're doing range is the set of values that we see as outputs for the function. So this function has its lowest output value, its minimum output value, at the y value of negative 10 and 1/3. And from there, they're all going to be higher than that because there's nothing down here for the graph. So that means our range is going to be from negative 10 and 1/3 to infinity. So here, you'll notice I put parentheses around the infinities. That's because we don't have a set value for infinity, so we cannot include an infinity. Whereas with the range, we do have an actual point at this negative 10 and 1/3, so we can actually include this value. So we need to put a bracket around that value to indicate that it's included in the range. Another kind of function we could have is an absolute value function. Like this, f of x is equal to the absolute value of x minus 1. These absolute value functions can have an intake of any real number, and they will spit out another real number. So that means our domain is going to again be from negative infinity to positive infinity. For this particular absolute value function, because we did not add or subtract anything outside of the absolute value, that means that the outputs from this absolute value are going to always be anywhere from 0 to any other positive number as large as we can imagine. So that's why our range is going to be from 0 to infinity. This thing can actually spit out a value of 0, which is why I get to actually include this value of 0. And again, I cannot put the inclusion or that square bracket around any of these infinities because we don't have a set value for them. Another kind of function you may see are radical functions. So for example, f of x is equal to the square root of x plus 4. For these radical functions, if we want real output values to come out of these functions, that means we cannot take a square root of a value that's less than 0. So for real outputs, we must take square roots of a value greater than or equal to 0. So I went ahead and solved that inequality. I took out the argument, x plus 4, and I said I want to know when it's greater than or equal to 0. I subtracted 4 from both sides to get this x being greater than or equal to negative 4. And this right here is telling me what the domain of my function has to be. It means that I can put any number I want to in this function as long as that number is greater than or equal to negative 4. And because we have the greater than and the equal to, when it comes over here to the domain, we get to have that inclusion with that square bracket. So our domain is going to be from negative 4 to positive infinity. Again, we put that parenthesis around the infinity because we don't have a set value for it. When I take these square roots, if we think about what happens when we take a square root, the primary root is always a positive number. On this function, there's no action coming out on the outside of the function of the radical. So the lowest possible value I can get from taking a square root is going to be 0, and everything else is going to be higher than that 0. So that means my range in this case is going to be from 0 to infinity. I can actually get a square root of 0, so that's why I get to include that value of 0 in my range. A couple more examples. The last kind of function that you may be seeing right now is going to be a rational function. So something like f of x is equal to x plus 6 over x minus 4. These are rational functions because it's got this fractional format where I've got variables in the numerator and the denominator. When we're dealing with rational functions, if we're looking for what's going to give us a real output value, we know that we cannot divide by 0 because we're not allowed to do that. It gives us a no solution. So I'm going to, again, pull off the part that's possibly going to give me a 0. That's going to be problematic, so the x minus 4. I'll set it equal to 0 to see where that happens. It happens when x equals 4, which means this is the value I have to actually omit from my domain. So to do that, any other number works except for 4. So I can have anything from negative infinity, and I can get really close to 4, but I don't actually include the 4. So I'm going to put the 4 in a parenthesis, and then I'm going to have this union because I'm going to hop over the actual value of 4, and then I'm going to have from 4 to infinity. So this means on one side I'm going to get really close to 4, as close as I can imagine, 3.99999, however many nines you want to put on there. I'm going to hop over the actual value of 4, and then I can continue again putting in values really close to 4 above the actual value of 4. So something very close to 4, like 4.000001. So really close. So to make that ability to, or for me to show that, I have to put parentheses because I can't put all those infinite possibilities directly below and directly above the 4. There's just too many. As you learn how to graph these functions, we have not really gotten into that, but we will. If I just graphed it on my calculator for now, or if I was given a graph, when I graph it, I'm going to see that this thing has this swoop going down, in this case this other swoop going down over here, and I have this jump that's occurring. This jump that is occurring is happening at this value of 4 that we identified. But we're also seeing that the curve is approaching this value here, but not crossing it and never really reaching it, which means my curve for my range, I can have anything from down here, so anything from negative infinity. I have these other values up here from positive infinity. And in the middle, I have almost everything except for this, what we call horizontal asymptote that we're approaching. And when I graph it, this horizontal asymptote happens to occur at the value of 1. So what that means for me is that my range is going to be from negative infinity to positive 1, and then united with the set from 1 to infinity. Again, we're putting parentheses around those 1s because we want to get close to them, but we can't actually achieve that output value of 1. So we have to leave our range like this. If we gave you some sort of piecewise function, and asked you to figure out the domain and the range on that function, when we look at this function, it has this closed dot at -5, which means it doesn't go on and on forever. It has another closed dot here at the x value of 1. There's an open dot down here at 1 all the way to 3, another open dot here above at 3 going all the way to 7, and then again a closed dot. So this graph does not continue like the other ones where we had arrows indicating for us that they kept going forever and ever. So my domain, I have output values anywhere from x being -5. Even at this 1, I have a true output value, all the way up to here at this next jump of 3. Both of these circles are open, which means I don't have a true output value for them. I have values that I get close to for them, but nothing that's going to come out directly if I put x equal to 3 into them. And then it keeps on going until I hit the value of 7, and it has a true output value for 7 because of that closed dot. So what that means is my domain will be from -5 to 3. Again, I have to use the parentheses because I don't have an actual value at 3. I can get really close to it, but not actually include it. And then from 3 to 7. And I will use those square brackets around the -5 and the 7 because they actually have output values, which means they actually get to be included in the domain. And that's what that bracket means. It means everything up to and including this value. The parenthesis means get really close to this value, but you don't get to include that value. And when we look at the ranges are y values. Here I've got outputs anywhere from 0 up to a value of 5. I do hit all of them if you look at these two parts of the curve, which means I get to say that my range is from 0 to 5. It's okay that there's this jump because this portion of the curve still covers the whole range of values from 0 to 5, and this one also covers it. I hope that helps. Please let me know if you have any other questions.